Hi, I'm Bobby Kohanam, and welcome to Draper Laboratory. Today I'm going to tell you about a project that we're working on for setting a hopper on the moon. A hopper is a vehicle that lands like a normal lander that we've seen in the past, but it propulsively lifts off the surface again and traverses across and lands in a new location. We're doing this as part of the Google Lunar X Prize. There's a lot of staff here at Draper that are working on this, and we have students at MIT. Behind me is Talaris, our Earth testbed vehicle. What we're trying to do with Talaris in the next couple months is demonstrate a terrestrial hop. So all 6 degrees of freedom, the whole vehicle freely flying in the lab and over at MIT. Standing by Talaris, our Earth testbed, and what we're doing with Talaris is demonstrating hopping for the first time. Talaris has 2 propulsion systems, one to take out Earth's gravity, our electric ducted fans, which are not on the vehicle right now but will be again soon, and a cold gas system, which you can see the tanks for here and some of the jets for here. And what that does is it actually mimics firing as though we were on the moon, using cold gas instead of a hot gas. We're going to demonstrate hopping in the lab and show how we can hop over hazards, how the hopper can be used to hop into very tight places like craters, small craters that we'll create in the lab. And then on the moon, we'll eventually be able to use this vehicle to hop over cliffs and mountains as well, something that no other vehicle is capable of doing. This is one of our first closed-loop tests. The vehicle is on its wheels, so it can only traverse in 1 degree of freedom, forward and back. We're closing the loop between our sensors and actuators for one of the first times, just to make sure that we know what we're doing and we can make the vehicle go in the direction that we want it to go. In this test, we're a little bit more risky. We're trying to test the limits of our 1 degree of freedom closed-loop ability. We have our actuators firing back and forth across the room, making sure that we can control the vehicle and are safe for future tests. This is one of our first closed-loop precision tests, where we're asking the vehicle to move a meter very precisely. And you'll see in the video that we move forward, we overshoot our point, and we fire back and reach within a centimeter of where we want to be.